Hi, in this video I wanted to show you how to use Upsolver to move high quality, high volume data from operational sources like Kafka, Kinesis, Postgres, MySQL, and even S3 into Snowflake in an easy and simple way. Now, in this demonstration I want to show you two ways to move data. The first one is using dbt. It's a code first approach, follows kind of software engineering best practices using dbt. And then the second one is a low-code approach using the Upsolver UI to accomplish the same thing. Once we've created these jobs to move data from the source to Snowflake, I want to show you two other things. The first one is how do we define data quality expectations on that ingestion flow, right? To make sure that we can validate the quality of data before it enters Snowflake. And then the second one is look at some data observability metrics that we provide out of the box that will make it easy for you to determine whether the data is good, maybe it has some issues in it, the freshness of it, and things like that. So you can actually detect outages and bugs and issues in the data before it actually enters Snowflake. So let's get started by going into the console. And I have a dbt project here that has a shared set of resources. And these resources are basically models that we use in order to build connections. So if we take a look at one of them, we can very quickly see that in this case is just a simple dbt configuration model that creates a connection. We just simply create the connection. We share the connection information like the AWS role, the external ID. If it's a Snowflake connection, then it's the JDBC URL, the username and password, and the same thing goes for Kafka and for other connections. I won't go into a lot of that detail, but what this does is allows us to use dbt to build these connections in Upsolver so other users can build models that connect to these sources without having to worry about it. Now, let's look at what that model looks like. So one of those models is this particular model that I created, and this is an incremental model that loads data from Kafka and puts it into Snowflake. Now, because Upsolver is a streaming first platform, we treat everything as incremental. Like we don't have static tables. Everything is incrementally updated. So in the case of dbt, all of our models are incremental. We both support insert and merge operations. But for the most part, what this does is it reads the data from the source and incrementally adds it to the target. Now, there's a few things that you can do on that data before it gets loaded into Snowflake. Specifically, you can exclude columns. So if there's columns you don't want in the target system, in my case, there's a password column that I don't really want in Snowflake, so I can exclude it. I can also create some or apply some low friction or simple transformations on that data. In this case, I want to hash the credit card column. I don't want to send that downstream in clear text. There's some other transformations that you can kind of stitch together with this to prepare the data and to clean it in, to secure the data before it gets loaded into your target system. The write interval is a way for you to configure how frequently you want to update the data in Snowflake. In my case, I want fresh data. I want to be as low as 1 minute, but in many cases, this may not be necessary. You need maybe 15-minute freshness or an hour freshness. You can easily configure that property here, and then Upsolver will only update the data in Snowflake on that interval. The second one here is the create table if missing. So this is a convenience property that says that if you don't have a table already created in Snowflake, we will automatically create one. And then based on the schema that we detect in the source, we'll create the right columns and the right data types for that. And as data gets, as the schema of your source evolves, we will automatically add or modify columns in your target system inside of Snowflake. So if you don't want to touch your schemas, you don't want to worry about updating columns and things like that, set this property and let Upsolver do everything on its own. And then we define a primary key. And then we have a select star statement here that simply selects from the Kafka source system and start loading data directly into Snowflake. So this is really all there is to it. So let's do that. Let's now build our dependencies. And these are the connections that we have in a shared library. And then we're going to run it. So let's do dbt run. I'll give it a second here to complete. All right, perfect. So now everything completed. Let's switch over to switch over to our browser. And what in the browser we see is that on the left side we got Upsolver, on the right side we got Snowflake. I'm going to switch over to here so we can see the connections that we created. So here on the left side, we can see that we have a Snowflake connection. We can click on it, we get some properties, and then we have the Kafka connection. We have a couple others in here that we're not really going to use, but these are these are basically the connections that we just created. Now we also created the job, and if we switch over to the jobs here, we see that there's a job, jobs created here. We're going to click on the Snowflake one. And it's going to take a few minutes because once the job starts running, it's actually waiting for events to show up in Kafka because we're not looking at old events, we're looking at new events. So because this is an auto-generated set of data, it takes a couple minutes for the data to generate. But generally, we're just going to sit here and kind of wait for some of these numbers to populate. In particular, we're looking for rows, rows scanned. Complete execution. We're looking for written rows. We're looking for data written. So once these numbers starts to increase, then we know that we have data flowing, and we can go check out our Snowflake. Okay, now we've waited a few minutes, and we're starting to see some numbers coming through. We can see the max number of scans today. So we get a bunch of data coming in, discover data. These are the number of rows that were written to the target system. How many bytes are written. We can see there's 8 columns that were written to the target. So if the schema changed, more columns get added, this number will increase. So there's a lot of really good numbers here in our job monitoring page that we can look at. So let's switch over to Snowflake. We can see here that originally we didn't have a table. Now let's refresh it. We see that there's a table created. We can see here the columns that were created. See no phone number. Sorry, phone number is there. No password. Let's click here on preview. Cool. So now we see all the data. We can see that credit card is actually hashed. It's exactly what we wanted. So perfect. There's also this one column here that's called the Upsolver event time. Right? And this column is actually a really important column because it actually tells you when Upsolver actually inserted that particular row into Snowflake. So if you want to know the freshness of that particular row, or when was the last time a table was updated, this column here is really important for that. All right, cool. So now that we've done this, we understand sort of what a simple job looks like. We know how to build it with dbt. Let's take a look at the same thing, but this time do it using the low-code wizard approach. So you can see here in Upsolver, we have this card here. It says Kafka to Snowflake. There's Kinesis to Snowflake. We have others as well. So we're going to click on that. And we can see that we already have a Kafka connection here. That's okay. We created that one using dbt. If you needed to create your own, you can click on Create New and pass in the properties. But in this case, we're just going to use this one. We're going to select a topic. Again, same thing, user info. We get a quick little sample of the data. We can scroll through. We can see all the values inside of that particular event. So we can understand, is it the right one we want? Do we need to tune or tweak some of these values if they're not what we want? But they look good. So let's just click next here. And then we have our Snowflake connection. Again, if you want to go to a different warehouse or a different Snowflake environment, you can do it here. But we already have one, so no need to do it again. We'll go here. We'll pick my usual one, and then we'll pick a table name, and then we'll click next. We're kind of validating that that table doesn't exist yet, so we'll create it automatically. Again, same thing as you saw in the dbt model. We can choose how frequently we want to update. We can choose when to start from. We can choose if we want to do any kind of deduplication. And then we choose which columns we want to exclude and which ones we want to mask. So we're going to choose to exclude this one, and we're going to choose to mask the credit card one. Actually, let's not do that. And then go here. And then we can see that there's, we can actually here review the job that was created. Remember, everything in Upsolver is based on SQL. So that wizard kind of wraps that SQL experience in an easy to use low code environment. but at the end of the day, it still generates SQL that you can interact with it, you can test it, you can version control it, and you can modify it later on. So it's a simple statement, right? We just, creating a job. As before, we're basically copying from Kafka, a particular topic, and writing into Snowflake. I'm not going to create it just because I already have one running, but that's kind of what it looks like. And then it goes through the same process. You look at the monitoring page, you see data is flowing, and then in Snowflake, the data is available. So that's pretty much it for the low-code environment. All right. The next thing I wanted to cover is how to set data quality expectations. So let's go back. In Upsolver, we have this concept called worksheets. And it's basically a SQL IDE. On the left side, you see all your connections. Here's a Snowflake. Once it populates, we can see this is my table here. We don't really need to worry about this right now. But what we need to worry about is the job that we created. This is the one we created with dbt. So the first thing we want to do is we want to actually add an expectation. What's an expectation? Expectation is a rule that you add to a particular job in Upsolver, an ingestion job, that checks the columns that you defined for a particular, for a particular set of rules that you define. And if that rule is violated, then you either warn about it or you can drop that rule altogether. So in this particular case, I'm altering my job and I'm adding an expectation. I call it ID not null. And inside of here, I'm going to check that the user ID is not null. And when it's violated, I'm going to simply warn. So in this case, I'm not going to delete. I'm not going to drop, but I'm going to warn you that there's that violation happens. Now, what I can do in Upsolver, I can actually run a show create job statement, and that's going to show me the job that was created and all the properties. So this is very similar to what you saw in the dbt model, but the main difference here is that we've added an expectation, right? And you can add a bunch of different expectations. There's a variety of rules that you can apply here as long as they evaluate to a Boolean expression like a true or false, then everything is good. But you can add these in here. So now we know what our table looks like. Very cool. So now we've added the expectation. Now this is sample data, so the expectations aren't going to really get violated. I'll have a separate video where I show you that. But what we can do is in Upsolver, we have this idea of a system table. So system table has two different subtables. The first one is information schema, similar to the information schema in Snowflake in other systems, where it just simply tells you information about the entities in the platform. So clusters, columns of tables, connections, jobs, etc. Columns of tables are interesting because it gives you information about that particular column, the schema, if there's any type evolution. That's kind of interesting stuff that you can do with it. But in the other table that we have is this monitoring table. And this is more statistics and information about the health of the system itself. So there's one particular for expectations. In this case, I want to be able to run a select star on the expectation table that shows me how many times expectation that I just created was violated. So in this case, of course, I don't have any failures in the system, but so there's no violations, but we can see that expectation ID not null that I created wasn't violated today and wasn't violated at all, right? So this today, triggered today, basically tells me how many times in the 24 hours of today did this get violated, and how many times in total over the lifetime of that expectation was it violated. So is it a today issue, or is it an issue that's been kind of growing over time? And I can tell that very quickly just from looking at this one particular table. Cool. The next thing I wanted to show you was data observability. So one of the cool things about Upsolver is that because we're a streaming engine, we have the ability to look at data as it comes in near real time and actually calculate and process a bunch of different metrics and profile the data to make it easy for you to tell whether things are changing, if they're changing or trending in a bad way or in a good way. So in this particular screen, you can actually select your Snowflake table, and we can see here that we have a couple different things. The first one on top is the events over time. So this is a way to tell you how many events are coming in and if there's any issues with the data. So it's a quick way to detect whether you have spikes, dips in the data, maybe you have an outage. So this is, in my case, this is just sample data, so it's very predictable. But in reality, you'll have a constant stream of data coming in, but you may need to draw that data may drop if there's an outage or something like that. The same thing goes for these statistics here. Now we can look at the columns themselves. We can see the names, we can see the types. We can see this column density. Density is a powerful column that tells you whether that the values in there include any null values, which means that if a user ID is 100%, that's good. But if it drops below 100%, it means that there's some null values in that column, and that's a bad thing, right? That can mean that I cannot merge data into my target system. We also have top values. We show you whether that value has repetition, that column has any repetition in it. So if you're expecting that column to be completely unique, then the repetition should be false, right? There should be no repeated values in there. That's a powerful way for you to determine whether the right data is in that column or not. There's also these columns at the end here called first seen and last seen. These are great. These are really good and powerful columns because it tells you when is the first time we've seen a new column being introduced to the table, and when is the last time we've seen a column being updated. So the first seen tells you was a new column introduced, when. So if the date is different than other columns, then you know that's a new column that was introduced. The last seen tells you that if the date is an old date in the past, then you know that column was not updated any recently, right? So that's kind of an indication that there's a problem here. Either the column was deleted upstream or there's a bug in the application or in the system where that particular column is not being updated. And with that said, I think that's pretty much it. There's a lot of different capabilities in the product, but this is a quick summary, a quick run of how to be able to take data from source operational systems and bring it into Snowflake, applying data quality expectations and having full-fledged observability and monitoring on top of that. So you know exactly what you're putting into Snowflake, the quality of it, and the reliability of it. And that's the power of Upsolver. Thank you so much for your time.